Cisco Kenna API. Create an asset and assign a vulnerability to that asset. All right, before we get started, Kenna does a very good job of documenting its API, and you can check out all the details here, from asset tagging to audit logs to high-risk vulnerabilities to creating assets. All of that information's here, and it's very prescriptive. You can come in and fill in the fields that are outlined here and actually go through a real dry run using your environment and determining the outcomes based on your testing. Now, the languages available are Shell, Node, Ruby, PHP, Python, and as well as C, C#, and all these others, including PowerShell, are all included in the API documentation. Pretty neat. All right, so I've created a script here, and I'm just using the CLI. The first thing I'm going to do is ask a couple questions. I want to grab the host name, the IP address, the operating system, and the owner. And I need an API key, and that's put away in a file that's secured, and I reference it on the fly and throw it into a variable called API_key. And now what I'm going to do is just give some idea of what we are going to create. We're going to create an asset, and we're going to leverage that API and all the variables that we filled in: hostname, IP address, operating system, and owner. Then we're going to dump that into output.log as well. And so we'll create the asset with the attributes, and then that output log file is going to be parsed so we can identify the asset ID that's created on the fly. We're going to throw that into a variable, and we're going to use that to be able to assign a vulnerability to it. Now, I've got waiting 30 seconds because there is a delay once you run the command before it shows up in your platform. So I do give it a little bit of time. 30 seconds might be way too long, but it's good enough for my use case here. The next thing we're going to do is we're going to go ahead and request that asset so we can look at all the details that we filled in. Then we're going to enter the vulnerability to that asset. And in this case, 2021 44228 for those that know Log4j. That's the Log4j vulnerability. The ID, in fact, is 78 within Kenna. I'm asking the individual that is executing the script to enter the vulnerability ID. We're going to use that ID to assign to the asset ID that we discovered from the output.log file. See the variable there. And we also included a static status of open. And then we're going to validate the assigned asset here. So again, we wait 30 seconds, and then we're going to be able to look at the data. So let's give it a try. All right, go ahead and run that script. So enter a host name here. Now, usually your scanners are going to do this. There might be other reasons why you want to add an asset into your risk-based vulnerability management platform, Kenna, and this is an example of that. So IP address, we entered the operating system, and we're going to give it a business owner as well, or enter the owner of that asset. It gives you a little bit of an idea of what we're creating here, making sure that it is correct. Go ahead and hit enter. And it's reading the output log. It's grabbed the asset ID. That's 42 for this specific asset. And again, we're waiting for 30 seconds here. I fast forward it, but there's the output in JSON. And we're going to come back to that in a minute. At the same time, we're going to go ahead and assign 78 or 2021 44228 to that asset, which is Log4j. And it'll also wait 30 seconds to show the output. So let's look through the output here. We see the asset ID of 42, the created at time, the operating system, the locator, that's the host name that we created, the department. We can also see IP address. Again, it referenced the host name. So all of that are things that we had added to the API call. Now, we could have added a whole bunch more. I just kept it to those 4 attributes. Now let's check the vulnerability that we assigned to that asset. So we can see vulnerabilities here, ID 78, and we can see it's open, the created date. This is the identifier as well. We've got the Nessus XML that has contributed to the data source that we're referencing here for that particular vulnerability. And you can see the solution details, the CVE ID, the description details. And we can see here some things like popular target, active internet breach, easy exploitable, malware exploitable, remote code execution, Now, all of this is key in understanding the risk of that vulnerability. And that's it. Now, let's just jump over to the interface real quick here and let's have a look at what we can see. We're already in the asset test 192-99 and we can see their fields there, remote code execution, and all the parameters around it. When we drill in, we can see the description, the fix, the known exploits, known malware. And where did that come from? That came from Nessus XML Tenable feed that we've got coming into the platform itself. Now, we automatically created the asset and we assigned it this vulnerability. Also see the details here, the owner, the IP address, the host name, when it was created, and the operating system. And there's some other fields here we could have also added. Pretty neat.